All right. You're welcome. Now let's have our script as usual. And today we are going to work on the Titanic, the data set on Titanic. I hope you went through it, you checked it and saw what it entails and what is in it. Okay, now let's load it into our R environment, into our source, so that we can analyze it. Let's do that. I don't know, my machine is getting, okay. Now, as you can see, this data set, and I hope you looked at it, you can see these variables, the different columns, are all categorical variables. The values in here are categorical. They are not numbers. They are not numerical. They are not integers. They're just categorical. Therefore, I want us to convert them into factors instead of
Bluetooth mode. AUX FM mode.
Sorry.
Bluetooth mode. AUX mode.
Let me try to mute these people. Okay. Now let's go on. So this data is in form of, these variables are in form of characters. Characters are just names. They are not numbers, just names. They are recognizing them as just characters. So you want them to convert them into factors, categorical variables. These are levels. These are variables with levels. Now this is a Titanic data set. You all know about the famous Titanic. The Titanic, that this is the ship that was very famous. I don't know whether it is a true story or whether it is fiction. I'm not sure, but I've watched the movie, the Titanic movie. So this data set is about that Titanic. Therefore, we want to convert these characters into categorical variables. We want to convert them into factors. And in the first category here, the first variable here, it is class. Which class did each of the individuals which were in that ship occupied? Now there was first class. Let's convert that into factors. There was first class. There was second class, third class, and there was a fourth class of the crew, the members, the captain, the people who served there, the waitresses, I don't know what the hostesses, whatever. So those were the classes in that Titanic, in that ship, that big ship. When it comes to age, there were two factors. Age, you had adults, you are either an adult or child. Okay. And then this is sex. You are either factors there. You are either male or female. In those days, there were no things such as intersex, I don't know, transgender. But nowadays, people are more inclusive. Now, when it comes to survival, you either survived or did not survive. So survival, so yes or no. Either you survive or you did not. So we would want us to work with this data. Now let's copy it here. Let's cancel that. Let's paste it here. Now let's read it. Okay. Let's view. Now this is a class, first class up to the crew, age, adult and child, sex, male or female, survived, yes or no. Now let's first get, let's load another package, the library, the scheme.r package, scheme.r, the scheme.r package. So let's scheme our data. Let's go through our data and see what it entails. The data is Titanic. Okay. Let me modify my panels. Not appearance panel layout. Let me put my console here. Okay. All right, I want my console here. Now, class, now as you can see, there are no missing values, but as you can see, this is the first category variable on classes. We have the crew, which was 885 people. The third class had 706 people. First class had 325. No, first class had 325, yeah, and the second class had 285 people. There were 2,092 adults, 109 children, so there are no many children, so it's not so many children were on that ship, Titanic. Males, there were 1,731 males and 470 females, so it was really but masculine there. So people who did not survive were 1,490, and those who survived were 711. So only 711 survived. Okay, so we can also get a glimpse of that data. What is in that data? So we have class, these are the classes, these are factors. So, and you can see that we can also get to know the structure of this data set, structure of this Titanic data set. Okay, so we have the class with is a factor with 4 levels, age 2 levels, hex has 2 levels, survival has 2 levels. Now, let's try to, we can also do summary. Let's do a summary of that data, see whether I got to give summary of Titanic of that data set. Okay, first class had how many people, age, sex, just the same statistics we had the other side. Now, let's do some plots. Okay, I would like to introduce to you a very important function called the table. Hereby we construct or create a contingency table. You just write table. We'd like to know, according to gender, how many survived. What is the differences? Just to show us in numbers. So to avoid issues, let's just attach our data here. Let's attach it. Attach Titanic. Okay. All right, so let's have a table of gender and survival. Okay, no, there was no gender, it was sex, sorry. Sex. So here is the output. So according to the survival, 367 males survived and 1,364 did not survive. And the females, 344 survived, 126 did not survive. So more females survived. In essence, more males survived, but in ratio, as you can see, that more males died compared to female, and we look at the ratios, but that's not for now. We can also check something else. Let's have a look of whether your sex determined which class you are in. Let's do that. Yeah, class. Let's see what happens. So first class, how many males were there? 180. How many females were there? 145. So there were more males in the first class than females. So in the second class, also more males than females. In the third class, also it has to go on like that. And the crew, we have more men working as crew compared to women. Let's also do a table of age, whether you are a child, you had more chances of survival than being an adult. Okay, let's see. So as an adult, how many survived? 654 adults survived, but 1,430 did not survive. And children, 57 survived, 52 did not survive. Okay, so children were a few, about 109. So that shows you the differences. What else can we look at? Class and what? Therefore, let's go now to statistics. Now these ones, let's us call them tab. Let's give them, let's assign them objects tab. Let's give this other one tab 1. Let's give this one tab 2. Okay, sums up. Okay, let's run them again. Okay, let's do some statistics here. Now, whenever you have data or variables that you want to test and all of them are categorical variables, the test that is appropriate for such a case is what you call the chi-square test. You must have come across the chi-square test. Every time the variables that you're testing against are all categorical variables with either 2 or more levels, you do a chi-square test. When the variables that you are doing research on, for example, you can do according to class. Did the class determine whether you survived the class? When you're in for the first class compared to the person who is in the crew, is there a difference between them? Okay, so you do what you call a chi-square test. So when you don't have any of the variables being numerical or integers. So let's do, it's called a chi-square test. Chi-square. It's called a chi-square test. Now, this chi-square test is called a test of independence. It's called chi-square tests of independence. So we want to know whether your survival was dependent on the class that you are or not, or whether your survival was dependent on your age, or whether your survival was dependent on the class that you are in, whether your survival was dependent on maybe, what else can we say? Whether it was dependent on class, age, or sex. So our main thing here we are checking is survival. People who survive, this is a catastrophe. So did your survival depend on the class that you are? Or did your survival depend on the age, whether you are a child or an adult, and whether you are male or female? If you are male, are your chances of survival higher or lower? If you're a child, are your survival chances lower or higher? So we are testing for independence. So therefore, our null hypothesis, let's say that survival, number 1, is independent of, let's say, the class that you are, whether you're first class or second class, whether you survive or not, that did not matter which class you are in. Therefore, the null hypothesis will be, the alternate hypothesis, sorry, will be that survival was dependent on the class. Therefore, we do a chi-square test. So let's call it chi. Let's call it chi. So you do chi-square test, just using the test there. And the test that we want to do is of class and survival. So we don't have that tab there. Let's have it here. Let's have tab number 3. Let's call it table. And then we look at class, the class that the person was, and survived, whether it mattered. Okay, so we are doing a chi-square for tab number 3. For tab number 3. So let's run that. Let's see what our chi tells us. Okay, here's a problem with chi. Okay, this is the Pearson's chi-square test of independence. Therefore, the p-value here is less than 0.05. If it is less than 0.05, therefore it means that the class that you were had an importance, had an influence on whether you survived or not. So means maybe those who were in the first class survived more than those who were in the third class. And as you can see, if you look at tab 3 here, let's run tab 3. Look at the crew. The crew, so many of them died, and only 212 were saved. These are the largest categories of people died. Then the third class died more. Then the 167, and then 122 in the first class. So fewer people died in the first class compared to crew, third and second classes. So if you are in the first class, your possibility of surviving was higher, because even you look here, those who survived in the first class are more uh, than others, except for the crew here. You can see the crew are a little bit more. I wonder why those people survived. Maybe they had the techniques. So it means that they are dependent. The class that you are influenced your survival outcome, whether you survived or not. Therefore, as you can remember, there was this command, the attribute command. Let's get what is contained in our chi. So we have statistic, the parameter, the p-value, the method. So we have the expected and the observed. You remember, if you have done by hand chi-square test, it is the observed minus the expected over the observed. Or is it the expected minus the observed over the expected? I think something of that sort. So you can check the chi, and you can check the expected. Is expected class expected, and you can have here, let's check the observed chi, the observed. So your survival was not independent of the class that you were. So let's do another chi-square test, chi2. And in this case, you're going to do chi-square test, and you're going to check whether you are, this tab 1, this whether you are sex determined whether you survived or not. Okay, this is tab, the first one. So let's run that. Let's see, chi2. So also, so if you are female, your chances of survival are higher than if you are male. So it is dependent whether you are male or female. Okay. You can check so many other things. You can check, let's have another chi-square. Let's have chi3. Let's have another chi-square. You can explore your data as you want. Chi-square test. Let's whether sex and class were related. The class that you went, whether your gender dependent on the class that you were placed in or the class that you got. Stop. Let's do chi number 3. Okay. So all these things mattered. Now we have done the chi-square. There's a point of plotting of which we just showed the table. Let's plot now. Let's plot tab, the first one, sex and survival. See how it was arranged. Let's see, this is what has brought us. So survived, no, yes. So proportionally more males did not survive than those survived, and proportionally more females survived than those who did not survive. You can see the size here shows the size of this box. These are mosaic plots. The size of this shows the number of people, so it shows you the proportion and also the numbers which were higher. So the females who are survived are more, even because even their number was smaller. Let's plot also what is happening. Let's plot tab 1. Tab 1 is of sex and class. So This category for males, this is a category for females. So first class, the males were fewer compared to the females, but proportionally, I don't think it makes sense. So the crew in that ship were the males were quite a number, the females were quite very few. There were more, proportionally, there were more females in the third class compared to males. So this just shows you, and it gives you an idea of the occupation, not the occupation, I mean the people who are in that ship. Let's plot tab 2. That's it. Tab 2 is on age and survival. Let's see. So age, adults. So more adults died proportionally compared to children. That's obvious because even there were many, as you can see. Okay, so this gives you the size. The size. See, the adults were more than the females, the children. We can plot the other one. Let's plot tab 3. Okay. Yeah, survival according to class. First class, second, third, and all that. All right. So that is a chi-square test of independence. That's why you check whether your survival is independent of the class that you are, whether your survival is dependent of your age, whether your survival is dependent or independent of age, sex, or class. All right.